Now, another problem. You can try this one out if you want, or just watch on if you're not quite ready to do it on your own. Same scenario, but you find a bank offering the same APR, 2.5% on a CD that compounds. This time we're compounding daily. So every day we're calculating interest and adding it back into the account to get more interest later. How much will you have in 5.5 years? Same amount of time, and we still want to think about if we take 5.5 years, and we're talking about daily compounding, so we're talking about 365 days per year, and that's what banks will use, even if it's a leap year like this year. So 5.5 times 365, that gives me half of a day, 2007 days plus half of a day. They're not going to give us half of the day, I'm pretty sure. So we're going to round that one to 2007. We round down on these because they aren't going to give us a whole extra day because we came in at noon on a particular day. All right, so then we can write out our formula. It's going to be that same formula, A equals PV times the quantity 1 plus R over N raised to the NT power. PV is still going to be my present value of 5,000, my starting value. 1 plus R is going to be 2.5%. This time I'll use the 0.025, so you can see that in action. And the number of compoundings daily, that's how many days are in a year. So my N is 365. So over here I have a 365 raised to the 365 times my T, and that was 5.5, remember? And that came to 2007.5, but remember, we're not going to get that half day of interest, so we'll call it 2007. And now I have my formula all filled in, so I'm looking at 1 plus 0.025 over 365. That has to be calculated first, and then raised to the 2007th power, and finally multiplied by the 5,000. So let's try that out. Push equals a lot on your calculator, then it helps your calculator figure out the order of operations. And I would not count on your calculator doing your order of operations correctly because we run into lots of trouble there. So equals 5,000. And inside the parentheses, I have 1.000, 4 zeros, 6, I'm counting them, 1, 2, 3, 4 zeros, and then 6, 8. And it goes on. I'm not going to write it all, to the 2007th power. 2007th comes next, so to the 2007, and then an equals. And now I have 5,000 times 1.14735, and it goes on and on again. Last operation, multiply by 5,000 times 5,000 equals, and now I'm getting money 5736.78, and the next digit's a 5, so I'm going to have to bump that 8 up to a 9. So I will have 5,000, or you will have $5,736.79. You can see that it's about 60 cents better than our monthly compounding. Compounding every day earned us about 60 cents. And you'll see that as you increase the number of years and or as you increase your starting balance, that there will be a bigger difference between monthly and daily. But with 5,000 and 5 years, it's not large enough on either side to give you the really big differences. So then the question that we were just talking about, which bank would you choose? So I would choose the daily compounding, but I'll only earn 60 cents more.